Welcome to the video summary series for Pedisco's Introductory Statistics textbook. In addition to chapter summary videos such as this one, Introductory Statistics also offers podcasts, virtual tutor e-learning, homework activities with anti-cheat and auto-grade functionality, and detailed instructor resources. Find out more at pedisco.com/introstats. For now, over to the author.
Hi, I'm Sean Thompson and welcome to the second summary in the Pedisco Introductory Statistics series. In this one, we're going to go over presenting data. In particular, we'll be going over presenting categorical data, presenting numerical data, and presenting relationships. Now, we could be flippant and say we present data because it looks nice. And this isn't wrong, it's sort of true to an extent. When we have a bunch of raw data, that will be how the data starts off, but it isn't really any good to anyone in that form. When we say we present data, what we mean is that we provide a kind of visual or graphical summary of the data so that we can detect trends in that data. So we'll start with categorical data, which usually starts life as a list of observed categories in a sample. Let's take an example. Let's say the city you live in has proposed that they want to knock down the local library to make room for a highway. You've surveyed 200 people about their opinion on this proposal, and in the survey people can say they either agree, disagree or don't care. The data from this survey will be a long list of 200 observed responses. Now in this form you can't quickly answer many questions about the data. Questions like, do more people agree with the proposal or disagree with it? So different ways of presenting the data are going to help you be able to do that. Now to start with, you can count the data. In particular, for each of the 3 possible categories, you can count how many times each one is observed in the 200 responses. Then you can present this in a table called a frequency table. And already, just by looking at this table, we have a better feeling for the data. If we want, we can also provide the relative frequency table, which shows the proportion of data values that fall in each category. We can put numbers like these into a chart to get more graphical. A common chart is the bar chart. Now the bar chart is a chart that visually shows the number of values that fall in each category. There's a vertical bar for each category, and the height of each bar represents the observed frequency of that category. So the bar chart gives the same information as the frequency table, but it's more visual and we can see what the data is doing. But there's also the pie chart. The pie chart is a circle divided up into slices, and each slice represents one of the categories in your data. And the size of each slice represents the proportion of values that occur in each category. So this chart gives the same information as the relative frequency table, but it does it in a way that lets us quickly look at it and get a feeling for the data. So we've just gone over presenting categorical data, and now we'll look at numerical data. All the same principles apply. We want to convert plain old raw data into graphics that help us get a better feeling for it. One major difference is that numerical variables tend to be able to assume lots more values. So we'll find that we need to group values together. For example, say you're studying dexterity, and as part of this you get 200 people to catch items tossed to them. Each person continues catching items until they drop one, and you record the number of items they successfully catch. Now, for these 200 data values, there's no limit to what the values could be. Compare this to the survey we mentioned earlier, where there were only 3 possible responses. To make it easier to manage numerical data, we often group values together into classes and then count the number of observed values in each class. This is a frequency distribution table. Now, like with the categorical data, we can convert these numbers into a chart. And for numerical data, we call the chart a histogram. So here's the histogram for the dexterity study. It's a lot like a bar chart, but due to the fact that numerical data is more structured than categorical data, we can use the histogram to tell us a lot more about the data. In particular, we can look into things like where the middle of the data is, whether or not the data is symmetric, and whether there is any skew in the data. Now this talk is just a summary, so I won't go over looking at these things in detail here. If you want to see these aspects of a histogram in more detail, you can read all about them in the Pedisco Introductory Statistics textbook. What I'll move on to now is time plots. Sometimes we collect and keep track of data over a time period to see if there are any trends over time. For example, a retail store might record sales figures each month over the course of a year, starting in July. What the store can do in this situation is that it can put these data values into a time plot. which is a graph where the horizontal axis represents time and the vertical axis represents the data being studied. So the retail store fills in points representing the 12 data values, the 12 sales figures they recorded at the time they recorded them. This is known as time series data, and a time plot is how you present such data. To finish off this summary, we'll have a look at presenting relationships. Now this is the topic that comes up when you have two variables and you want to see if the variables are related in any way. How you present the relationship depends on what sort of variables you have. You might have two numerical variables or two categorical variables, or you could have one of each. Now we'll be spending most of our time talking about relationships between two numerical variables. In that situation, we use what is called a scatter plot. Now a scatter plot is a two-dimensional graph with one axis for each variable. The values of one variable run along the horizontal axis and the values of the other variable run along the vertical axis. You draw the scatter plot by placing points on the graph corresponding to the data values you collect. So let's take an example. Say you're looking at a year of 100 school students and you want to see if there is a relationship between the score each student got in the mid-year exam and the score they got in their final exam at the end of the year. So for each of the 100 students you have two numerical data values, a mid-year score and a final year score. And these 100 pairs correspond to 100 points on the scatter plot, like this. So what does this tell us? Well, the scatter plot can basically tell us two things: what type of relationship exists and how strong the relationship is. For the type of relationship, we go to the shape of the graph. These points tend to follow a basic straight line, so we would say that the relationship is linear. For the strength of the relationship, we look at how tightly gathered together the points are. The relationship here isn't mathematically perfect, but at the same time the points aren't too scattered, so we would say that the relationship is strong. If points scattered wildly, like this one, for example, we would say that the relationship is weak. So we use a scatter plot to interpret the nature of the relationship between two variables. To get some practice at doing this, let's do a question from the Pedisco workbook. In this question, some data have been collected for the different offices of the Mean Corporation. In particular, the number of employees at each office and the amount of funding that office receives are recorded for every office in the Mean Corporation. This scatter plot shows the data for funding versus number of employees. And three analysts have studied the plot and offered suggestions for the relationship that exists. You're being asked which description is best. Ted offers the best description, so we'll submit that. And now we get personalised feedback and an explanation for the question. So that's the relationship between two numerical variables. What about if we have one numerical and one categorical variable? Well, this situation is quite common because in experiments you can often provide different levels of a categorical variable and then record the level of a numerical variable. In this case, we can still use scatter plots, but they won't look exactly the same. Here's an example of a scatter plot showing the relationship between a numerical variable and a categorical variable. And finally, what about when looking at relationships between two categorical variables? A scatter plot won't do here. Here we can use what is called a side-by-side bar chart. Let's look at an example. Let's say a survey is studying the relationship between the gender of a voter and which of three candidates that voter will select in an election coming up. So 1,000 men and 1,000 women are surveyed about this, giving us two frequency tables of data, one for each gender. And each table breaks down each gender's voting preference. Now the side-by-side bar chart is essentially two bar charts in one. The two genders are separated out, and for each gender we present bars to show the relative number of votes that each candidate got in the survey for that gender. And we can compare the bars between the two bar charts. So in this way we can look at the relationship between gender and voter preference. So that was presenting data. The key topics were presenting categorical data, presenting numerical data, and presenting relationships.